All right, so there are some rather interesting calculations we're going to need to do to be able to find out the percent of metal bicarbonate that's in our samples. And I'm going to go through that calculation through this video. I'm going to use sodium bicarbonate as my example, but if you used potassium bicarbonate as your unknown sample, obviously all that would change here is the molar mass of the potassium carbonate and potassium bicarbonate. Okay, so let's just assume here that we start with like X grams of the sodium bicarbonate. Okay, and this would be like the introductory activity. And at the end of the day, we're going to produce a whole bunch of this stuff. Okay, we'll call that Y grams. And that's the sodium carbonate. And we got the other stuff here, water and carbon dioxide. I think you could probably realize that in this case, the amount of grams of X is going to be greater than the amount of grams of Y. So if we went ahead and asked the question as question number 2 in the discussion does, where is the mass loss? We would say that the lost mass from this reaction is due to the water and due to the carbon dioxide. Okay? So if we wanted to calculate that mass loss, we could maybe simply say that the mass of the CO2 produced plus the mass of the water produced should equal total mass loss, because the bicarbonates will break down to the carbonates, but the carbonates won't break down any further. Okay, mass of CO2 plus mass of H2O equals the total mass loss. All right, so what I'm going to do is I am going to make the, I think, fairly valid assumption, and I'm going to just point out that the moles of carbon dioxide actually equal the amount of moles of water that are produced via this reaction. And if you look up in the balanced chemical reaction at the top of the page here, I think you'll all agree with me. There's 1 mole of water for every 1 mole of CO2. Okay, so I don't think that's a stretch. Now let me say this. Because of that, the moles of the NaHCO3, okay, they're going to equal 2 times the amount of moles of, let's just pick water, moles of H2O. I think we can all agree with that as well, right? Okay. The balanced chemical reaction, I've got 2 of these guys for every 1 of these guys over here. Okay, so for every 1 of the sodium bicarbonates that are produced, so that's 2 times the amount of moles of H2O. Okay, I don't think that's a stretch, so hopefully you're with me at this point. Now we're going to start a little bit of substitution. All right, so I'm going to go to a new page here. Let's put that chemical reaction back up on the page. And let's go back to that previous assumption here that the moles of the bicarbonate, so the NaHCO3, equals 2 times the moles of the water. Okay, good. All right, now let's go back to that idea of mass loss. How are we going to figure out that mass loss? All right. Well, the mass loss, as we said before, is equal to the mass of the water plus the mass of the carbon dioxide. All right. So let's figure out how we can do that. Well, if we know the moles of H2O, we can get that into grams, right? Because we could divide that by 18 grams per mole. That's the molar mass of H2O. Right? And we'd have to take that and we'd have to add that to the moles of carbon dioxide. And very simply divide that by the molar mass of carbon dioxide, 44.01 grams per mole. I'm sorry, I'm saying divided by. That should be multiplied by, guys. Let me just do a little erasing here. A smaller eraser. Get rid of this line. Okay, and then I'm just going to put a multiplication sign in there. Just like that. Okay. And if you would do that, you'd be left with grams of each of these. But remember what I said back on the previous page. That was that the moles of carbon dioxide actually equal the moles of water. So we can do a little bit of reducing here. It makes our lives a little bit easier. And we can say the following. That's the moles of water times both of these molar masses added together, plus 44. And that's going to equal, if we kind of do the math there, at the moles of water, times 62 grams per mole. Okay. So again, to clean this up, we're going to finally state here on the bottom that the mass loss, the total mass loss in our experiment, is going to reduce down to the number of moles of water times 62 grams per mole. And again, we can combine the molar masses of carbon dioxide and water. It's a G there, sorry guys. We can combine the molar masses of carbon dioxide and water because they're a 1-to-1 mole ratio in this case. Okay? Alright, so let's take this bottom portion here, and then let's bring that to a new page. Okay, so let's remember this. Our mass loss equals the moles of H2O times 62 grams per mole. And I'm just going to go ahead and rearrange this a little bit again. I'm going to do a little bit of algebra. All right, I'm going to get moles of H2O by itself. So moles of H2O, right, that equals the mass loss divided by 62 grams per mole. Okay, grams would cancel out and be left with moles, so that should be pretty good. And let's go ahead and do a little substitution now. If you remember back from a couple of slides ago, we said that 1 mole of sodium bicarbonate equals 2 times the amount of moles of water. So let's sub that in. Okay, we said that this, okay, and we could rearrange that. We could say it's 1/2 times the moles of NaHCO3. Okay. So if we do the rearranging, we're going to get the moles of sodium bicarb divided by 2. Okay, because that'll multiply together here on the left side, and that equals our mass loss divided by 62 grams per mole. Okay. Alright, now one simple last step here is to get that 2 out of there, and we're just going to multiply both sides by 2 in order to achieve that. So let me get the 2 out of here. Place it on the other side, so we're going to multiply. Alright. So what's this giving us? Well, this is our final goal. What we'll now know is if we know how much mass loss there is, and that's an easy number to find, right? Because you'll have your mixture, you can heat it. At the end of the day, there's going to be a difference in mass. That's your mass loss. If you take that, you divide it by 62 grams per mole, which is the addition of the molar masses of the water and the CO2. And you multiply it by 2, you'll be able to come up with the number of moles of sodium bicarbonate that were in your original mixture. Well, we know the molar mass of sodium bicarbonate, don't we? Sure. So if we know the molar mass and we know the moles, I think you should be able to see the math that gets us into grams of sodium bicarbonate. And from there, we should be able to calculate the percentage of the bicarbonate in our original mixture.